Element 43 on the periodic table of elements is technetium. This is Norris Teaches Science. With me, Ms. Norris, is a physical science edition video in the physics section of physical science. This is also talking about energy conversions. I have done previous videos on energy calculations and energy basics. Now we're going to talk about converting between kinetic and potential energy and real-world examples. So your goal for this video is to say, I can describe how energy is transferred between kinetic and potential energy in the real-world examples. So energy conversion. This is when energy changes from one form to another form. So examples are like kinetic energy to potential energy, or even mechanical energy to thermal energy. You see a roller coaster over here, and the GIF is showing how kinetic energy and potential energy is changed throughout the roller coaster. Now, when we talk about energy conversions, we need to talk about the law of conservation of energy, which states energy cannot be created nor can it be destroyed, can only be changed. Means the amount of energy you start with is the amount of energy you must end with. It's just the energies can be in different formats. For the first energy conversion we're going to talk about is the roller coaster. So I have 5 points up here, and we're going to talk about each point. So you go up to the first point, you're at the top of the first hill, you have the greatest potential energy. As you go down the first hill, at point 2, you are converting between potential energy and kinetic energy. Potential energy is decreasing while kinetic energy is increasing. But at point 2, they're about equal. When you get to the bottom of the hill, at point 3 here, your kinetic energy is at its greatest. Then as you go back up the next hill, you're having another conversion. This time kinetic energy is decreasing while potential energy is increasing. At point 4, they're equal. Then at the top of the next hill, potential energy is at the greatest. But the amount of energy you have between the whole thing is equal. It's constant. They're just in different forms. Another thing you could have is something called a pendulum. Right? A pendulum at point 1 has potential energy greatest. You're holding it up, you're about to let it go. When you let it go and it starts to swing down, conversion's happening. Potential energy is going down, kinetic energy is going up. At point 2, they're kind of equal. When it is perpendicular to the ground at point 3, kinetic energy is at its greatest at that point of the swing. And then it's going to start to swing back up. So we're swinging. We're going to swing back up at point 4. Another conversion is happening. This time kinetic energy is decreasing. Potential energy is increasing because you're starting to increase your height. And right now they're equal. And then when you get to point 5, potential energy is at its greatest. The thing about a pendulum is going to keep swinging back and forth. And the same process is going to happen. You're just going to reverse 2 and 4. The last real-world example is throwing a ball up in the air. So at point 1, you have just let the ball out of your hand. The kinetic energy is at its greatest. Now the ball is traveling up. When it's traveling up, the conversion is happening. Potential energy is increasing because you're increasing your height. Your kinetic energy is decreasing. And at point 2, they're equal. Then it continues up and you get to point 3. Point 3, your potential energy is greatest because you're at your greatest height. Then the conversion starts happening again as it falls down to the ground. Potential energy decreases, kinetic energy increases, and at point 4 they're equal. And then when they get to point 5, right before hitting the ground or coming back to your hand, kinetic energy is greatest again. And this is a little bit about energy conversions. I would go out there and learn about some other ones like thermal to kinetic or when that stuff happens. I did not mention about during like roller coasters, heat or thermal energy is produced during the roller coaster at the same time. We just did simplified versions with kinetic and potential. But go up there and learn some new stuff. But I hope you learned something today. I'm Mr. Norris. See you at the next video.